we're a distributed open source database. You can store and query JSON documents, but that's not what I'm here to talk to you about. I'm here to talk to you about product design, and particularly API design in the context of distributed systems. So what I'd like to do is tell you a little bit about the evolution of how we designed RethinkDB, what the design goals were, what we did, how we solved them for the first version, and then what happened in the process of watching users use the product, what we learned, what the problems were, how we solved them again the second time, and then maybe some of the lessons learned in this process. So hopefully by the time you come out of here tonight, you'll learn something new, I hope, about product development and how to do it right. So you don't have to do whatever you're doing twice like we did, and you can only do it once and get it right the first time. So just a little bit about RethinkDB design goals. So our product has two major components. The first component is letting developers build applications on top of RethinkDB. And it's about how do you store data, how do you query data, how do you update it, how do you do analytics, big data analytics on your MacBook Air, things like that. And, and I'm not going to talk very much about that today. I'm going to talk about the second component, which is ops. So once you've built your app and you deploy your database, hopefully on Compose.io, but there are other options, which you shouldn't pick. There are guys and girls who are actually responsible for running the database 24/7, and if something goes wrong, like they get a PagerDuty call at 3 a.m. and they have to wake up and fix it. So our goals for DevOps or operations, we had a couple of things we wanted to do. So we looked at various products. We looked at MongoDB. We looked at Cassandra, other stuff that was available at the time. And we basically learned that setting that up was a pain. Like going from one node to two nodes was just really, really hard. The learning curve suddenly just shut up like this. And then even if you're going from 2 to 3 or 4, it just gets progressively more complicated. You need more expertise. It's harder to run. Life's not good. So we wanted to do a couple of things. We wanted to remove all the pain from scaling a database. The idea was you started with one machine. Then the moment you need more, you need to shard, you need to replicate. We just make that super easy. We wanted cluster setups to be easy. Like if you're using Mongo, you have to set up different processes, and they have to kind of know about each other. There's a lot of configuration. We didn't want any of that. We wanted to make things really easy. And we wanted the people literally to click a button and make it happen. So our first version of the product was designed to make that work. And what I'd like to do now is I'll do an actual demo of RethinkDB version 1, actually the one you could download right now, and I'll show you how some of this works. And then we'll talk about the problems with it, what didn't work, and how we fixed it. So I'm going to switch out of this, go back to the terminal, and make it bigger so you can see what's going on. OK, can you see from here? Is that good? OK, so the first thing I'm going to do is start a RethinkDB process. And the server started up. And RethinkDB ships with this admin console, which is just a little web server embedded into the database. Sorry, I'm walking around again. A little web server embedded into the database, and you can put your browser to it and start doing things. Start looking at the cluster, running operations. So I'm going to do that now. I'm going to switch to Google Chrome and make things bigger and go to localhost 8080, which is the RethinkDB admin console. So this is the administration tool I was talking about, and you can do all kinds of things. You could see what's going on with the cluster. But right now I'm going to go to the Data Explorer, which is the part of the tool that lets you write queries and actually run them in the database. So I'm going to run a couple of queries here and then show you how sharding and replication works. So the first thing we do is r.table create. I'm going to create a table, foo. I'm not going to bother with actual table names. Run this. And we've created an actual table. And the second thing I'm going to do is insert a bunch of data into it. So I'm going to say r.table for insert. By the way, so this part of the product is about the experience of developers. And we're not talking about that here today, so I'm just going to kind of blow through this because I only have 15 minutes, and we'll talk about ops. So what I'm going to do is insert a bunch of data, and it's going to look something like this. You know, let's just say name Slava B dot multiply 1,000. So what I'm doing is I'm just creating an array of elements here, and like with one element and multiplying it by 1,000. So I get an array of 1,000 elements, and then I'm inserting it into RethinkDB. And I get a result back saying, well, we've inserted a bunch of documents. So just to show you that this worked, I'm going to say table count, and hopefully, yep, I get 1,000. So now we have a table with a bunch of data. And let's say people want to shard or replicate. The way RethinkDB version 1 works is you go into tables, and this is a list of tables here. Right now we have only one server, and I'm not going to set up a cluster in the interest of time, but it's also really, really easy. So we're going to go into table foo, and let's say I want to shard. So instead of having one shard, I want multiple. The way RethinkDB v1 worked is, and I don't know if you guys can see this because this projector kind of makes everything white, but you hit edit, and you say, I want X number of shards. So let's say in this context, we have 1. Let's say now we want 2. I'm going to hit rebalance. You see a little checkbox, sort of progress bar here. Things run, and now you've got 2 shards. It's that simple. And our premise was like, hey, we make this super simple for people to shard. Like if they have multiple machines, they could just do that in seconds. Replication is just as easy. We have 1 replica right now, but if I wanted to, I could say I want 3. You could just use this nice web UI to make the scale across data centers. You could set up as many replicas or shards as you want, and life's wonderful. So that's version 1 of RethinkDB. I'm going to kill this now and go back to my presentation. Which kind of neatly coincides with the noise outside. OK, so that's how RethinkDB version 1 worked, and that's actually the version you download today. So what happened when people saw this? We shipped this product, we showed it to users, and everyone, like the first thing we heard was, wow, that's awesome. I've never seen things run so easily. This is amazing to set up. I'm going to try this. And then they were like, but there are some problems with this. And as people started using the product and really running it in various scenarios, we discovered that this kind of setup, like it's really great when you're playing with the product. It's really great when you're doing simple apps, but it's not so great when you're doing something more complicated. And there were a whole set of problems with this, and some of them are here. So people started wondering, like, OK, I click shard, and I go from 1 shard to 2 shards. That's awesome, but like, what actually happens inside the server? Like, where does my data go? How does that work? I don't feel very comfortable with the system just doing it. I kind of want to know what's going on. Like, I see that progress bar, but what actually happens inside the cluster? What are the replication jobs that are going on? Can I pin my data myself to different machines, different servers? Maybe your algorithms are great, but maybe I have something specialized. I want to do that myself. You have this web UI. Can I do this programmatically? So people had all these questions. And the thing about these is it's not necessarily something people would actually need to do, like in production and in real scenarios. And in fact, if the system's designed well and works as expected, which it does, you should never, ever have to do any of these things. But it's still something people were concerned about. And if your users are concerned about something, you have to address those concerns, even if that's not necessarily something they're going to do or going to use. And beyond these design problems, there were more. As people got deeper into the product, they were like, well, OK, can I access cluster statistics? How do I monitor what's going on? How do I tell how much memory any given node is using, how much disk space, what's going on with the network? Like, there are all these questions that you just have to know the answers to. And then there were just sort of traditional administrative kind of problems, like, OK, if I run long-running queries, what's going on? What are they? If something's slowing down my database, how do I kill them as an admin? Like things like that. So we looked at all of that, and we said, OK, this system that we designed is really nice, but we kind of have to redesign it. And interestingly, the answer to all these questions was always yes. Like, yes, you can find out what happens. You can control where the data goes. We have tools to do that. You can figure out what the statistics are. You can do all that stuff. But all of it was kind of built by ourselves, for ourselves, as a bunch of backdoors into the system. So anytime someone asked a question, we were like, well, this isn't really well documented, but like if you do this thing and run this command and go to this URL, you could find this out. And it worked for people, but it just like wasn't good enough. It's not something people felt super comfortable with, and you had to explain it over and over and over again. So we designed version 2 of the clustering system that I'm going to show you now. And this is, so I'm going to switch, while the train runs. But this is a work in progress, so if stuff crashes, like, don't blame me. But hopefully it doesn't. OK, so I'm going to run a custom build of RethinkDB. This is a branch on GitHub called requel_admin, which you could check out if you were so inclined. I don't know why you would be, but you could. And this is a work in progress with the new clustering API. So I'm going to start that here, RethinkDB, and I'll start the node in exactly the same way as I did before. And I'm going to point the browser to localhost 8080. Make this a little bit bigger. And we're back. We're back in our admin console. It's the same thing, except there are some quirks here because we're porting it to the new API. And I'm going to go through the same process, except this time I'm going to show you how you'd get answers to all these questions. So let's create, and I just deleted all my data. So I'm going to create the table again. And table food, got it, table create. So I'm going to create a table again, and I'm not going to go through the process of inserting data into it because I don't have to, and you'll sort of see what I mean. So what we did to answer all these questions is we took all these backdoors and all these little URLs and little commands that were kind of incoherently designed for each special case, and we built a coherent system around it, a coherent API, where you could access all of that in the same way. And of course, RethinkDB is a JSON database. You store JSON in tables. So what we did is we created a sort of special database called RethinkDB. We'll probably rename it to system. And it has a bunch of system tables that give you a lot of information about what's going on. So just to show you what that looks like, I'm going to say DB RethinkDB, which is the system, system database, and list all the tables in it. So table list. And you can see there's a bunch of tables here that I didn't create. So all of that is created by the system. And it's just tables that give you a lot of information into what's going on. So for example, there is a table here called table config. And I'm just going to list everything in it. So table config. And let's see what documents are here. So right now, there is one document here because I created one table, the table foo. And this document is basically a configuration document for this table. So it tells you a whole bunch of stuff about, how durable the table is, what your settings were, how the write acknowledgement works, all the stuff that you could set up. And most importantly, it tells you where the data is located. So right now we have one shard, and it tells you, OK, there is the replica on this machine, badgirl local, and badgirl is my laptop. It's a delightful name that I'd encourage everyone to use, but not in our network. And it tells you what the primary server is. And if you start sharding and replicating, this document will reflect exactly what configuration of the table you want. So when you do something in the web UI, like change the number of shards, it actually updates this document. This document tells you, what the configuration is for the table. But what's really interesting about it, too, is that you don't just read from it necessarily. You could also write to it. So if I wanted to add another shard, and I wanted that shard to be located on a particular machine, I could literally run a recall command and write to this document, add another element, another machine name to this array. And the system would respond and actually, replicate data to it. And that's exactly what the web UI does. It runs like a higher level command that writes to this document. But you as a user now can see exactly what's going on, what the config is, and you can change it yourself, and you can set up low-level details. But what's also super cool about it is there are a bunch of other tables that tell you lots of other things. So if I look at table status is slightly different. Instead of telling you what the expected configuration for a table is, like what you want as a user, it tells you, hey, this is the real thing that's going on in the cluster right now. Like, this is actually what's happening. So what happens is when you as a user change the configuration file, change the configuration document, this document starts reflecting what happens in the cluster. It says, okay, we're replicating from A to B, and this is the status of the replication. And eventually, this document kind of syncs up and starts reflecting the configuration document you wanted. So anytime you change the config, this starts changing. You can see exactly what's going on. And eventually, the cluster catches up to the configuration you wanted, and you see that here. So you can tell exactly what's going on in your cluster. And I'll just show you. I don't want to belabor this. I'll show you one more table, which is server status. And server status tells you exactly what the state of any given server in your cluster is. And right now we have one, so there's one document. But if we added more, you'd see more here. And this has like when the server last connected, disconnected, the ports, like cache size, and all kinds of interesting things like that. So basically, you can see exactly what's going on in the cluster in any given time. And there's a bunch more tables we're adding, like we're adding a stats table, which reflects the cluster statistics and has documents for all the stats in the system. And we're adding a jobs table, which will show everything that's going on, like all the replication jobs, all the long-running queries. And what's really cool about this is all of this runs. This is the same infrastructure that you typically use, like write queries for. So you could actually write recall queries to query these documents. And for stats, you could like aggregate them any way you want. You could set up change feeds on it to view a real-time state of the cluster. You could write to these documents where it's allowed to make actual changes. So this is really, really cool. Like you could delete. So for example, in the jobs table, when there's a long-running query, you could literally delete that document, and it will kill the query. So it's a really, really neat abstraction for what's going on. It takes all these things and unifies them with a single API that people already know. And it kind of takes all these questions that they have and just removes them completely. And people look at this, they go, wow, like that's really cool. I actually understand what's going on now. So I'm going to switch back to the presentation here. Play from current slide. OK, so this is better in like a lot of obvious ways. It's accessible. It's coherent. It gives people a sense of confidence and control. Even if they never use this functionality, they know it's there if they need it, and it makes people just feel more comfortable with the system. It's scriptable. You can access it programmatically. You can write queries like, life's good. So what are the lessons here that we learned? Like, what's interesting about all of this stuff is that there are no actual fundamental changes to the underlying system. Like, there's no technology here. Anything that you could do now, you could do before. The difference is that it's just like more visible, more coherent, kind of more well-designed, but it's all cosmetic. And the lesson we learned, like, cosmetic changes legitimately, like, they really matter. Because what's cosmetic to you is not cosmetic to your users, and the way they perceive the system is totally different from how you perceive it. So like how much work you put into something is completely unrelated to how valuable they find something. And making a couple of changes just to make things easier for people can make them dramatically happier, more confident in your system, and just like they feel better about what's going on, and it's easier for them to adopt the product. And the other thing we learned is that it's really, really important to do like hallway usability testing. I don't know if you ever heard that phrase, but the idea is if you grab 5 people coming down the hallway and make them play with your product, you're going to learn 95% of what there is to learn about any problems that are going on. Like, you don't have to commission expensive studies. And all the stuff that like this process we went through where we build V1, we learned that people are unhappy with it, and then we have to build V2, which is coming out pretty soon, and I'm really excited about it. It's probably about a couple of weeks away, maybe a month away. But we didn't have to go through that process. Like, we could learn this on day 1 before we ship. All we had to do, like, literally was just talk to 3 people and have them actually play with the system, and we didn't. So I think, like, just having people play with your product or a prototype, you don't even have to build the whole thing, learn what they have to say, and then make the cosmetic changes to make them feel a little bit more comfortable can go a long, long, long way into having people feel better about your product and adopt your product. So download this at rethinkdb.com. Play with it. It's a really nice product if you're building an application. Like, you should try it out. And if you have any questions, ping us on Twitter at RethinkDB.